talk, we'll leave the groundwater environment and move offshore. I'm hoping we've got Professor Michael Heath. I've been looking out for Michael all afternoon and not managed to spot him, so I'm very glad you're here. Professor Heath is Professor of Fisheries Science at the University of Strathclyde and also links with the CUSP project with us with the Marine Alliance for Science and Technology for Scotland, MASS. And those of you who were here yesterday afternoon will have heard a couple of presentations from PhD students at the working through MASS, which was really interesting. So looking forward to hearing more from you, Mike, about urban dependence on coastal seas. Thank you.
Okay, thank you very much. Well, for the few surviving members of the audience, something completely different. No geology, no geochemistry, no groundwater. Completely different. Oh. Okay, well, Glasgow's economic power and its trading potential is really founded on the Firth of Clyde and the connection to the Atlantic Ocean that provides. And it's really through its shipping heritage that trading potential was developed. I don't think I need to tell you anything about the shipbuilding and the shipping, military, naval and passenger heritage of Glasgow. But there are other services that the Firth of Clyde provides for us. And probably everybody in this room at some point has benefited from those services, whether it's eating seafood, whether it's sea angling, the scenic value, the wildlife, or in my case, in my laser dinghy at the bottom there, sailing around on it, getting close in contact with it all. But it's the fishing role that I want to concentrate on, because despite chemical pollution and nutrient pollution, it's really fishing that has the biggest impact on the state of the ecosystem, on which all these non-shipping, non-transport ecosystem services really depend. So to introduce you to the fisheries of the Firth of Clyde, I've tried to make this little diagram which summarises the different types of fishing and how they developed over the years. So at the top we've got what we call the pelagic fisheries. Those are really the herring fisheries. These are the fish that swim up high up in the water column and eat plankton. Way back, drift netting was the way to catch herring. Walls of netting hung out in the sea, the fish swim into them, caught by their gills, and they're hauled aboard boats. In the 1860s, a new method of fishing developed called ring netting, where instead of just leaving the nets out in the water, the fishing boats tried to encircle a shoal of fish and then haul it in. And then later in the 1960s, mid-water trawling was introduced, where the power of diesel allowed boats to tow nets through the water. And lots of conflicts, lots of interesting stories around that. The next layer down is the demersal fish. These are the fish that live on the bottom, feed on the bottom, on seabed animals and feed on other fish. And traditionally, in times gone by, they were caught by line fishing, long lines set out in the sea with hooks and bait. Later, seine netting, using nets again to encircle patch of seabed and haul up the fish. And then again, trawling with the onset of steam and diesel engines. And then at the bottom we've got the shell fisheries. And there's a nice picture there of a Norway lobster or nephrops or langoustine or scampi, whatever you want to call it, creeping out of its burrow. And there's a very active fishery by both static fishing using creels, lobster pots, or similar to lobster pots or nephrops in the Clyde, and also trawling or dredging for these. And there are conflicts there between those two methods of fishing. Well, the herring fisheries go back many centuries in the Clyde. And for a long time, the herring fisheries in the Clyde yielded about 20,000 tonnes of fish a year. And the history of how that developed was really linked to the development of steamers which carried the herring up the river to Glasgow for sale and export, to the railheads that developed around the Clyde to rapidly carry fresh fish back to Glasgow to feed the population of Glasgow, but also for trade. And the fisheries also have varied depending on the demand for fish and the abundance of fish in the sea. But the sad story is that in the 1980s the fishery collapsed and there is now really no commercial scale fishing for herring in the Firth of Clyde. Maybe it was connected with the transition from ring netting to trawling. Also, the demand for herring decreased. But it's the same story with the demersal fisheries. They too have gone. So the fisheries for cod, haddock, whiting, plaice peaked in the 1970s. They're now almost zero. But instead, the shell fisheries have increased. So the fishery for nephrops in the Firth of Clyde is something like 20% of the UK catch of nephrops. It's an enormous fishery, very, very valuable. And there's some sense in which that's a consequence of the decline of the demersal fisheries, because the demersal fish are predators on the nephrops. So there's an intriguing story here, but it's not a good story as far as fish are concerned in the Clyde. And the consequence for Glasgow economy is that the speciality seafood restaurants that are are very popular in the Clyde in Glasgow are now almost completely unable to source locally caught finfish. Shellfish, yes, from creel caught, especially from creel caught nephrops, but locally caught finfish more or less unavailable in Glasgow. So it all has to be imported. So there's a long history of regulations intended to try and preserve these fish stocks, which go way back to the 1850s even, when there was warfare on the streets of Tarbert between the drift netters and the ring netters, and shootings in the street and all sorts of stuff, and ring nets were banned and then they weren't. And in 1889 the whole Firth of Clyde was closed to trawling because it was feared that those were damaging the herring stocks. And then it was reopened in 1962, but only outside the 3-mile limit, which is the sort of brown line that you see on the map there. And then finally in 1984 the whole Clyde was opened, and then 2001 those areas closed because to protect cod and blockades of harbours, and it's a turbulent zone for fisheries, is the Firth of Clyde. But it's also a turbulent zone in terms of the views as to what's going on. So in this graph you've got a questionnaire survey of the creel fishers and the trawl fishers in the Clyde, and the first they're answered, is the Clyde overfished? And the creel fishers say yes, and the trawl fishers say no. And is trawling sustainable? And the creel fishers say absolutely not. The trawl fishermen say yes, absolutely it is. So completely polarised views as to what's going on. And then in 2010, dramatic headlines. There was a paper came out in PLOS, Ecological Meltdown in the Firth of Clyde. And that was an eye-catching headline, if ever. And the newspapers certainly got hold of that. Clyde fished out, marine desert, blah, blah, blah. And it was all based on the landings, the amounts of fish that were actually being landed on the quayside, which is not really a very good indication of what's going on in the sea. It's just a reflection of what the fishermen decided to bring ashore and what they could sell. So the next year, another study, which had less dramatic headlines and therefore less press, but we actually went in and we gathered together all the research vessel survey data we could from 1927 to the present day, which had been collected by Marine Scotland and its ancestors, and tried to make some sense of that. So there were about 20,000 records of species counts in 1 centimetre size classes from those red boxes on the screen. So most of the sampling is concentrated in those red sentinel sites in the Clyde. We put all that together. And first of all, just to show you again the fisheries data, so on the right you're seeing the landings of fin fish and how they've developed in decadal intervals over the period 1960 to the present, and the rise of the nephrops landings. And now on the left you're seeing what's actually happening in the sea from the survey data. And first of all, we're seeing that the biomass of fish actually hasn't changed very much from the early part of the century. There's just as much tonnage of fish in the sea as there was, but it's all small stuff. So the red bits is the biomass of fish which are smaller than 40 centimetres, and the green is the fish that are larger than 40 centimetres. And the landings track the big fish in the sea. But actually, it's small fish that have taken over the system completely. And you can see that in the second graph down, where we're looking at the mean body length of fish in the sea, which has declined from 50 centimetres to something like 20 centimetres. And bear in mind that the legal landing size for the main commercial fish is like 27 to 30 centimetres. So there just aren't any fish there which are of commercial interest. And in the bottom graph, we've got a measure of biodiversity, which this particular measure is called species evenness. It's the extent to which species are evenly distributed through the community. So a value of 1 would be that all species are present in equal biomass. A value of 0 is, well, you can't get a value of 0. But the lower the value, the more concentrated the biomass is in fewer species. And this is exactly what we've seen. So in this picture shows the range of species which make up 85% of the biomass in the Clyde in different periods of time. When you see back before trawling was allowed in the Firth of Clyde, remember that was opened up in 1962, it had this enormously diverse range of species. A lot of very large-bodied, slowly reproducing species like the small sharks and the big hake and rays. And then as time's gone by, we've lost all those, and what's left is just one species by 1995 to 2004. Well, It's not quite true, because the species richness, the number of species that were present was the same, but the biomass was all concentrated in this one species, whiting, and that's a really bad sign. More recently, it's improved a little bit, but still 70% of the biomass in the Clyde is concentrated in this one species. So just to summarise the evidence that's emerged from all this research, so the economic output from fisheries in the Clyde is still high, but it involves only a few boats and employees. The targeted fisheries, fin fisheries, are more or less gone, and it's now dominated by nephrops, and the Clyde demersal fish community has undergone this transformation into one that's dominated by a few species, and mostly, or almost entirely, small fish which have no commercial value. So the key scientific questions that we need to answer are there any interventions that would promote a change in the state of the Clyde to one in which large fish are abundant again? What are the benefits of a 3-mile limit on trawling? That's banning trawling close to the coast. Are the bycatch rates of fish in the nephrop straw fishery inhibiting recovery, and what would be the benefits of any of marine protected areas in the Clyde? But really, fundamentally, there's a political issue that needs to be addressed, and this isn't something that science can answer. It's what does society want the state of the Clyde to be? It's actually quite economically productive in its present state. Why would we want to turn it back into something else? And that's a societal question which only politicians, our elected representatives, can answer. Science can say, well, if you want that, this is how we might get there. And that answer to that question has got implications for Glasgow and for the local authorities all around it in terms of what port facilities and infrastructure might be needed in the future, future employment and training of people working in the fishing industry, food supply and transport for the city, and tourism planning, because restoring fisheries will have implications for wildlife in the Clyde as well. Well, there have been some developments down that road, but it's been quite bumpy in the last few years. So there's been various sort of initiatives to try and sort out these issues. A lot of the early debates focused on the conflict resolution between different sectors of the industry. But this year, 2014, there was the Clyde Summit, which was hosted by the Scottish Government in Glasgow, where one of the issues on the table is what are the aspirations of society for the state of the Clyde. Starting to talk about those sort of very high-level issues. And I'll just finish with my only bit of geology. Nice volcanic plug, the Ailsa Craig rock in the middle of the Firth Clyde. Thank you very much.
That was, for me, absolutely fascinating. Completely outside my area. Maybe because I'm based in Edinburgh, I thought I knew quite a lot about fisheries on the East Coast, but I had no clue really about the West Coast, so that was really interesting. Any questions?
Have there been any habitat mapping studies taking place?
Yeah, certainly. I mean, there's been a lot of work to map the Clyde habitats, particularly funded by SNH. There's a big impetus to map, especially the inshore habitat, which is believed to be very important for the sustainability of the fish populations.
I take it that increasing the size of the fish is a function of age and not adaptation of the species to predation.
Well, that's really interesting. Because two things have happened, particularly to whiting and haddock, is that their growth rates have decreased, and also the age and size at which they mature has decreased. Now, there's a possibility that that is a genetic response to intense exploitation. Fishing is very size selective, so by fishing very intensively, we selected out the fast-growing, later maturing individuals and killed them and brought them ashore. And what's left is a genetic strain which is predisposed to slower growth and smaller maturation and smaller maximum size. So this is a really big impact on the recoverability of the system.
Is there any data on water temperature over the same period of time that might be a factor in?
There is, just by chance. I thought somebody would ask that. So these are monthly water temperatures from 1950s to almost the present day. And there is a warming trend in the Clyde, particularly from the 1980s onwards. So the underlying deseasonalised trend is warming. And certainly we would expect that to have an effect on fish growth rates.
One quick question, so I'll come to Alan. Linked to that, is pollution an issue?
Well, not pollution as such, I don't think, but nutrient emissions down the river and through the estuary could well be, because I mean there's been big efforts to reduce the nutrient load in the Clyde and the estuary, and you would expect that to have an effect on the plankton production in the Clyde to reduce it, and therefore that could well be reflected in the productivity of the fish stocks. Yeah.
Oh.
Okay.
Is that linked to nitrates?
Yes.
Management as well?
Yes.
One more question, Paul?
Really interesting impacts on biomass biodiversity. Are there any correlations then with top predators in the system, like seabirds or sea mammals, that might be being affected by the size of fish available for them to eat?
Yeah, we unearthed recently some very interesting data in the 1640s in the archives of the archbishops of the west of Scotland. They'd done a questionnaire survey of the herring fishermen in the Clyde, and they'd asked them to record their observations of seabirds and mammals that they encountered when they were fishing. And the Firth of Clyde is extremely rich in large cetaceans and basking sharks at that time. Well, there are still some basking sharks, but not many cetaceans left in the Clyde except the small porpoises and dolphins. And you know, that's a combination of factors. There's a North Atlantic-wide decrease in the populations of these animals, but also a local effect of changing availability of fish.
We'll move on now to our last talk. Thank you very much.
Thank you.